A NASA spacecraft is set to make history today, getting closer to the sun than any other human-made object.
NASA just pulled off something that sounds less like science and more like a dare. They flew a spacecraft straight into the sun's atmosphere, not near it, not past it, into it. And somehow, instead of being vaporized into a cloud of very expensive regret, it survived and started sending back discoveries that are turning decades of solar science upside down. The crazy part? Scientists expected answers. What they got were even bigger questions. Because the closer Parker's solar probe got to the sun, the stranger our star became. Today, we're diving into the most shocking things NASA discovered after touching the sun. And trust me, some of these findings make it seem like the sun has been freelancing its own laws of physics. Let's start with the challenge that made this mission seem impossible from day one. Sending a spacecraft to the sun sounds about as sensible as bringing an ice cream cone into a blast furnace. The sun's outer atmosphere can reach temperatures of millions of degrees. Millions. Yet Parker's solar probe survived thanks to one of the greatest engineering achievements ever built. Its secret weapon is a massive carbon composite heat shield designed to withstand punishment that would instantly destroy ordinary materials. While the side facing the sun gets hammered by extreme temperatures, the instruments hiding behind the shield remain surprisingly comfortable. But here's where things get weird. The corona is incredibly hot, yet surprisingly thin. Think of it like standing inside a scorching room filled with very little air. The particles are moving insanely fast, but there aren't many of them to transfer heat. It's one of those situations where physics sounds like it accidentally skipped a meeting. Still, Parker has to keep that shield pointed directly at the sun every second of every day. One wrong turn and the spacecraft could go from historic mission to space debris in a matter of moments. Fortunately, Parker survived, which is impressive, because getting there was arguably even crazier. Parker's solar probe isn't just fast, it's ridiculously fast. At top speed, it travels around 430,000 miles per hour, making it the fastest human-made object in history. At that speed, you could travel from New York to Tokyo in less than a minute. Meanwhile, most of us can't even get through a software update that quickly. NASA achieved this by using repeated flybys of Venus. Each close encounter acted like a giant gravitational slingshot, gradually pulling Parker closer to the sun while boosting its speed to record-breaking levels. The result was a spacecraft moving so fast that it could dive deep into the sun's most dangerous regions, collect data, and escape before conditions became even more extreme. Think of it as the ultimate smash-and-grab mission, only the vault is a star, and the security system is made of superheated plasma. Then came the moment that changed history. For decades, scientists believed there was an invisible boundary where the sun's atmosphere effectively ends. The problem? Nobody knew exactly where it was. That boundary is known as the Alfvén critical surface, and in April of 2021, Parker crossed it. For the first time in human history, a spacecraft entered the sun's atmosphere. Let that sink in for a second. Humanity touched a star. Not physically, of course. Nobody packed sunscreen and went for a walk. But scientifically speaking, Parker had crossed into territory no human-made object had ever reached before. And almost immediately it found something surprising, because the edge of the sun wasn't behaving the way anyone expected. Scientists had imagined the boundary of the corona as something relatively smooth and predictable. Instead, Parker found chaos. The edge of the sun's atmosphere is filled with giant peaks, valleys, folds, and irregular magnetic structures. Rather than looking like a clean spherical shell, it resembles a constantly shifting roller coaster built by an engineer who was paid entirely in caffeine. The discovery was so unexpected that Parker sometimes crossed in and out of the sun's atmosphere multiple times during a single flyby. One moment inside, one moment outside, then back inside again. It's like crossing an international border 5 times without ever changing roads. That finding alone forced scientists to rethink where the sun truly ends and where space officially begins. But the next discovery was even stranger. Because while moving through the solar wind, Parker spotted enormous magnetic structures twisting through space. Scientists call them switchbacks, and honestly, the name doesn't even begin to capture how bizarre they are. Imagine magnetic field lines streaming away from the sun in straight paths. Then suddenly one of them bends backward, flips direction, and snaps forward again like a cosmic whip. That's a switchback. Researchers once believed these magnetic distortions were relatively rare. Parker discovered the exact opposite. They're everywhere. The sun produces them in astonishing numbers. It's the scientific equivalent of thinking you've spotted a rare animal, only to discover it's secretly running the entire ecosystem. Even more surprising, evidence suggests many of these switchbacks originate directly from the solar surface itself. That means Parker isn't just observing strange solar behavior, it's helping scientists track these magnetic structures back to where they're born, and that discovery leads directly into an even bigger mystery. A mystery that has frustrated scientists for more than a century. Because if magnetic switchbacks seem strange, wait until you hear this. The sun's atmosphere is somehow millions of degrees hotter than the surface beneath it, which makes about as much sense as walking away from a bonfire and suddenly feeling warmer. For more than 100 years, scientists have been trying to solve one of the biggest mysteries in space. How is the sun's atmosphere hotter than the sun's surface? That shouldn't happen. It's like standing farther away from a campfire and somehow getting hotter. Yet the corona reaches temperatures of millions of degrees, while the visible surface remains much cooler. For decades, researchers debated whether magnetic waves, tiny solar explosions called nanoflares, or some other hidden process was responsible. Then Parker's solar probe did something no telescope on Earth could do. It went straight into the action. The spacecraft detected evidence of powerful magnetic activity and magnetic reconnection events, moments when magnetic field lines snap, reconnect, and release enormous amounts of energy. While the mystery isn't fully solved yet, Parker has provided some of the strongest clues ever collected, bringing scientists closer than ever to an answer. But just when researchers thought things couldn't get more dramatic, the sun decided to put on a show. During one of its closest approaches, Parker witnessed a massive coronal mass ejection, a giant eruption blasting billions of tons of solar material into space. That's impressive enough. But the real surprise came afterward. Parker observed long streams of solar material falling back toward the sun. In other words, not everything escapes. Some of the sun's own eruptions get pulled back down, almost like a cosmic recycling system. Scientists had suspected this happened before, but Parker provided some of the clearest observations ever recorded from inside the corona itself. And that discovery matters for a very important reason. Everything Parker is learning helps improve our understanding of space weather. The same solar wind and eruptions it studies can affect Earth, disrupting satellites, GPS systems, communications networks, and even power grids. The better we understand the sun, the better we can predict its next move. And that's what makes this mission so remarkable. Parker's solar probe wasn't supposed to survive where it went, yet it became the first human-made object to enter the atmosphere of a star. It revealed a wrinkled, chaotic solar boundary, uncovered magnetic structures scientists never fully understood, brought us closer to solving the coronal heating mystery, and witnessed solar eruptions from a perspective no spacecraft had ever achieved. Not bad for something roughly the size of a small car. And the best part? The mission isn't over. Every close pass delivers new data, new surprises, and potentially new discoveries. Because despite being the center of our solar system for billions of years, the sun is still keeping secrets. And for the first time in history, humanity is close enough to hear them. If you enjoyed this video, make sure to subscribe, because the universe has a habit of being far stranger than fiction, and we're just getting started uncovering its biggest mysteries.